Hi guys, in this episode I'm going to show you how Oshu-queue works. So let's get started. We start from the general overview, then we go through the source code, then we run an example together, and there will be a fun bonus at the end. Here on the screen is a general overview of the Oshu-queue, and there are 3 players, 4 if we count Gun.js server. It's an orchestrator, publisher, and subscriber, also known as a worker. And that's how it works more or less. So we have an orchestrator in the middle, and a publisher that sends a QM, which is a queue message, to orchestrator. Then orchestrator sends it to subscriber as a job message. And they exchange those messages forth and back. There's a separator, and there are 2 different messages, just to have those 2 sections completely separate, because they may have different needs. So let's go to the code, see how it is done. Let's start with the orchestrator. It does the most complex part of the queue, but because it is core, so it's a good place to start. So first, we initialize. There are some configs, but this is not that detailed. So here we initialize. There's an init that comes from the common class, and that works for all 3 players in the same way. Once we are authenticated and account was created, if it's just created, it displays all the information that we should store in our env file. Also, we create 2 certificates. One is for the incoming messages, and the second one is for subscribers. Those certificates are public. Also, we publish our key that we want publishers and subscribers to use to encrypt messages for Orchestrator. And once this part is done, we can start listening for messages in those 2 queues. So let's start from the incoming messages, because one message in Gun.js can be populated, however to call it, multiple times. We are listening only for the messages that has status created. If message is in progress and will come here, it will be just ignored. And it is worth to mention that there are some assumptions. First assumption is that it doesn't make sense to modify data without changing status, but status can be changed without changing data. And also, publisher cares about the result, not about processing the whole message. So here we add to the internal object 2 values. One is a key and of the message from the queue, and the other one is just a data. We use this class just to decrypt encrypted message. Once this is done, we can go try to find subscriber that can take care of this message. Here we go through the internal object of subscribers. We check their status, and if type of the subscriber matches type of the message, and current subscriber is not busy with some other task, then we can do assignment. And assignment is pretty straightforward. We just take a task, and we take this job ID. We create, we set some values for the subscriber for its job. It's just the ID, status, and the payload from the original publisher's message. And we set a timestamp when this happened. Then we prepare this message. Here we store a job message that I will talk about later, and we encrypt this message again to make it safe for this distributed database, because we never know who will be listening for this data. So having data encrypted, we can put this to the subscriber. Then we can set our internal status to assigned, so it is not created anymore, and that will prevent from the another assignments. Here is a internal log queue where we store just information about the progress of the job. This is just for further use. And here we store in the queue in the original message, we just change a status of it to assigned. So this message will not be processed again. And now we can go to the second queue for the subscribers. Yeah, here we listen for all the nodes in this queue, and we compare them with the last timestamp when it was modified. Now we are ready to get the real data if we know that it was modified. And having this data, we just check if this subscriber has no job in both ways. Yeah? It might be never set like here, or it might has finished job, so the timestamp was set to 0. Here we decode the message sent from the subscriber to us, and if the subscriber is free, then we are going to find a job for him. And the same is here. If the status of the job is smaller, so it was updated, the incoming message is newer than the last we proceed, we just decode the message and process. We just take tasks. We are looking for tasks that have status created, and the message of the type of the queue message is the same as the subscriber type. If so, then we can assign this task that we talked about it already. How the processing looks like, because the same message can come to the processing a few times, it might be already proceed. So we check if it's still in our internal object. If it's not, we just skip it. Here is just a decoding of the message, and that's what we are going to update. We are going to update a status, and the status comes from the job, and this job is what the subscriber sends to us. Yeah, so we have a status provided by the subscriber with the payload from the subscriber. Those two values we assign to the message, the queue message from the publisher, and then we encrypt this for the publisher. We prepare this update object, and we do update in the queue for this job. If the job is done, we just remove that entry that we checked here. Also, for the subscriber, we set the internal values to false to make him free. And that's actually it for the orchestrator. So let's go to publisher. Here you can see the init function exactly the same as in orchestrator. First, what we need to do is to take from the public its EPUB for encryption, and then certificates just to be able to store information in the orchestrator namespace. And to send a message, we need to create a message with some payload, and then just send this message. And sending message, we prepare a key. That part is required by certificate, and just to make it more unique for particular publisher, we add this ID to the key as well. Then message is encrypted using publisher orchestrator's EPUB that we fetched earlier, and is added to the queue under this key. And there is a message listener that's listening for these changes. Here we assign the previous message to compare this with the current one. And if there are differences, that means that we can do something with it. So we decode the message. It's called read. It's here. We use this EPUB from Orchestrator and our pair keys. And that's the only actually status that publisher should care is done. If it's done, we delete this message from the internal queue and we are disabling this listener. And subscriber is very similar to publisher. Here's init again. We take EPUB certificates. Just the queue is different, yeah, because we are going to use queue for subscribers. And first thing that we want to do is to report status. It's like when we do this first time, it's like a registration. But later on, we are going to use it to report our current status. And here is the listener in this queue for jobs. So how reporting status looks like? It is object of job status or job message that we can just convert to object. If we provide those two values, the payload will be encrypted. And here's just a callback and certificate, nothing fancy. And job listener is if the current subscriber is free and the data that came has a job, it makes sense to decode. Next, assign this job to the internal properties. And resolver is something provided to the constructor. That's what will proceed incoming messages. Here we check again if there is a job, because there's always in this place here. There might be always a job, because even if there will be a false, but it will be encrypted by a CM, so it will be a string. So that's why after decoding, we need to check if there is a real job or there's just a false encrypted. So if everything is fine, we can deconstruct this to the object and pass it to resolver, waiting for processing. Once we got the result, we set the status as done. We set the timestamp for now, and we are reporting status. Once we report the status with this job, then we are going to report that we are free. That's why we have to call this report status again. So let's go to some examples. A server is just a server. Orchestrator, this is just actually that code. All other is just to make it working, continue working in a node. Publisher, the same. It is just this part. Yeah, so we initialize. Once we are initialized, we can create a message, anything we want, and then send message like here, and here we wait for response. And here we have the subscriber. Here is our resolver that receives a payload. This is an example, yeah, so that's why we are waiting for the math key. It is this one. Here we do eval, never do this in a real code. And here we initialize and provide resolver. So that's actually everything that happens here. So now let's see how it works in a console. Before we go to any running code, we need to have end file like this. So let's start server in the first tab. Next, we are going to start Orchestrator. Once it's started and we would like to reuse the same account in the future, we can copy all this code, all this part to our end file. But for now, let's copy just the public, and we are going to paste it here. Okay, we go to, so let's run publisher. The same. And here we have our message populated. Yeah, we do something cool, and there's some math equation. So time for a subscriber. And our subscriber was initialized, started, registered to the orchestrator, and immediately it gets the message, prepared response with this. So we can see it here as well. Yeah, so there was our initial message. Then it was assigned to, so we received status 1, but still no response. So it is that publisher can ignore. Here we have status 3, which means its task was done, and here we have response coming from our subscriber. So let's jump into small panels. And the queue, Oshu-queue, was meant to be used in a Node.js, but we can do some trick, and we can browsify it. So first we need to install gun.js if you don't have it installed yet. Then we need to run browsifier like this. Yeah, so we take our publisher code. We want to output it as a Oshu publisher and publisher browser.js file. So here I have running gun.js server. Let's start brand new orchestrator. So here I have those two JS files. Let's go to publisher. Here we create the same, almost the same as its publisher. Yeah, so this is actually this part. Here to subscriber, the same. And let's see how it works in a browser. Obviously page is blank, so let's publish some jobs. Yeah, so here's our message, exactly the same as we could see previously in a console. So here create a subscriber and the same. Yeah, the same message. We received status 3. Let's create new job. As you can see, subscriber received a new message, the same result, right? And here we have status 0, 3. Number 1 is missing, and that's because, as I said earlier, when Orchestrator will get a message that the task was done, it removes this from queue, and all other statuses like 1, 2, or whatever are just ignored because the job is done and we don't care about the other messages anymore. Probably if I will refer this a few times, it might be, yeah, like this one. Yeah. So the status number 1 came before 3, so it was also propagated and received by the publisher, but status number 3, that's what the publisher should really care. Yeah. 2 refreshes, and here we have those responses. So actually that's it, how it works. Remember, this is a very early stage of this queue messenger system, and there might be some issues, so thanks for watching, and report all issues in a GitHub repository. See you next time.